In this video, we will be discussing reflections. Now, whenever convenient, I will refer back to these rules about reflections. So my advice to you would be to take out a sheet of paper, copy this chart down right now so that you can refer back to it whenever you need it. Now let's use the point -2, 3 to briefly practice how to use these rules to find reflections over the x-axis, y-axis, the line y equals x, and the line y equals -x. So this rule says take the point, keep the x value the same, but change the sign of the y value. So I'm going to keep the x value the same, but I'm going to change the sign of the y value. So this would be the reflection of the point -2, 3 over the x-axis. If I want to do a reflection over the y-axis, this rule says change the sign of the x value, keep the y value the same. So I'm going to change the sign of the x value, so that'll be +2, and I will keep the y value the same. So notice when there's a negative here, it just means change the sign. Okay, so notice this one doesn't have any negatives. So we're not going to change any of the signs, but instead of xy, we will write yx. That just means switch the order. So I would take this and I would switch the order. So this would be 3, -2. We simply switch the order. And then if I want to do a reflection over the line y equals -x, notice that both of these have negatives in front of them. That means we're going to change both signs. And we're going to reverse the order. So I'm going to reverse the order and change the signs. So when I reverse the order, the 3 is going to come over here, but I'm also going to change the sign, so it'll become a -3. The -2 will go over here, but I'm going to change the sign so it will become a +2. Okay? Also keep in mind, if this is the y-axis and this is the x-axis, when we talk about the line y equals x, we are talking about a diagonal line 45 degrees. This is the line y equals x. And if we talk about the line y equals -x, we're talking about a line going down at a 45 degree angle. So this is the line y equals -x. Alright, let's look at the first problem. They are talking about a reflection over the line y equals -x. So first of all, remember which rule we're using. This one down here. xy becomes -y, -x. Alright, that means we changed the signs and we switched them around. Okay, we want the pre-image of point f prime. F prime is right here. Okay, so this is the pre-image, and this is the image, right? Before, after. So we know that the image, f prime, is the point 4, -2. Be careful. Notice that they're counting by 2's. See the 4 there? So one mistake that students will make is to think that this is the point 2, -1. But you have to look at these numbers. So they're counting by 2's. So this is actually the point 4, -2. So that is the image. Now what they're asking us for is the pre-image. So if this point was switched around and the signs were changed, if I want the pre-image, I'm just going to do the same thing. I'm going to switch them around again, and I'm going to change the signs back. So if I switch these around, the 2 will go here and the 4 will go here. If I change the signs, instead of a -2, it should be a +2. Instead of a +4, it should be a -4. Alright, so that's it. This should be the answer. This should be the pre-image. Let's see how we did. Boom! 2, -4. In the next problem, they're asking us what is the relationship between the segment R prime and the segment S prime. Well, here is R and here is R prime. So this is the segment R prime. Okay, now here is the point S and here's the point S prime. So here's the segment S prime. So how are these two related? They are parallel. So this should be the answer right here. RR is parallel to SS. Boom. Okay. This is the symbol that means perpendicular. So if one of them went like this and the other one went like that, you know, with a right angle in between, that would be perpendicular. But looking at the two segments, this is not what happened. They are parallel to each other. Okay, this is the symbol for parallel. In this problem, they're asking us which triangle must be a right triangle and why. Before I answer that question, please understand that when you do a reflection, okay, say that this is my original point P, and then I want to do a reflection over this blue line, so it's going to end up over here somewhere, and this is going to be the image P prime. So you need to understand that if I am doing a reflection, if I connect the pre-image and the image, it is always going to form a right angle. All right, this segment joining the pre-image and the image is always going to be perpendicular to the reflecting line. All right, it's always going to form a 90-degree angle. So I'm sure that's going to show up in this problem somewhere. So anyway, we have the image of triangle ABC after reflecting over the line EG. Okay, so we have the pre-image and the image. So all of these line segments are going to be perpendicular to the reflecting line. So see how we have the point A and A prime. Okay, so this segment connecting them is going to be perpendicular, just like I showed you down here. See how I have C and C prime? Again, the segment connecting them is going to be perpendicular to the reflecting line. Okay, so that's probably going to answer the question. So let's see. Triangle ABC is a right A prime, B prime, C prime. Is that a right triangle? Let's see. A prime, B prime, C prime. We have no way of knowing if that's a right triangle. All right? We're looking for a triangle that's going to involve one of these two right angles that we just found. So I don't think that's it. How about triangle ADC? Okay, let's see. ADC. That's this triangle right here. No, there's no right angle in here that we know anything about. So I don't think that's going to be it. So that's another no. What about triangle BCC prime? Okay, so triangle B, oh, there it is, B, C, C prime. Okay, is that a right triangle? Nope, none of these are going to be right angles as far as we know. So I'm running out of choices. So I'm really hoping this last one is going to be the answer. Triangle BGC. Okay, so here's B, G, C. Oh, there we go. That's going to be the answer. See how we have our 90-degree angle right here? Of course, it's going to be 90 degrees on both sides. Okay, so this 90-degree angle right here makes triangle BGC a right triangle. So this one is going to be the answer. Boom! Okay, in this question, what is the rule for the reflection? So first of all, we have to decide, are we reflecting over the x-axis or are we reflecting over the y-axis? That's thing number one. So I hope that it's just obvious to you that the x-axis is the reflection line. Alright, you have the one triangle above, the one triangle below. You know what I mean? So for example, this point and this point, alright, the pre-image and the image, boom, we're clearly they're being reflected like a mirror over this line, the x-axis. So that means we are not talking about the y-axis, so we can throw out this and this as a choice. Okay, it's not going to be either of those. Alright, so it's going to be an x-axis reflection. So it's just a matter of will it be the first one or the second one. So this is just a matter of the rules that we talked about earlier. Again, this is where your notes come in. If you did not have this written down, then chances are you're not going to remember this right now. So write it down so you can refer back to it. So here is the rule for the x-axis reflection right here. Okay, so the rule is xy, the reflection over the x-axis is x negative y. Okay, we keep the x the same and change the y, x negative y. So that's it. That means it's got to be this one. So it's not this one. It's got to be kabam. Alright, this is just plain the correct rule. Let's check it out. Yeah, the power of taking notes. So this problem is very easy if you have this copied down. So make sure you do. Okay, last problem. Which statements must be true about the image of triangle MNP after a reflection across the line EG? Check all that apply. Well, let's do a little sketch first of all. So here's N. If I go the same distance over here, then this would be N prime. Okay, if I do the same thing with M, alright, that's going to be like about here, and this is going to be about here. Okay, so this is going to be M prime and P prime. Alright, so this is just a rough sketch. It's not perfect, but it should be good enough for us to answer the questions. Okay, so remember, vocabulary-wise, this is the image. Okay, you know, the reflection is the image, and the original is the pre-image. Okay, so keep that in mind. Now, let's see how many of these things must be true. The image will be congruent to triangle MNP. Yes. All right, those are definitely going to be congruent. So when you do a reflection, it doesn't change the size or the shape. So yeah, it'll be congruent. The orientation of the image will be the same as the orientation of M and P. That will not be true. Okay, orientation has to do with the order of these letters. Okay, this is backwards when you do a reflection. Notice if I went clockwise around this triangle, it would be like N, P, M. Okay, N, P, M, for example. Now, what if I went clockwise around this triangle? All right, I'll start at N prime. But this time it'd be N prime, M prime, P prime. All right, it's a completely different order. That's what they are talking about when they talk about orientation. Okay, so doing a reflection changes the orientation because it flips everything backwards. Okay, line EG will be perpendicular to the line segments connecting the corresponding vertices. That's going to be true. That's what we were talking about on the previous problem. All right, here is a line segment connecting the corresponding vertices N prime. And of course, that will be perpendicular to the reflecting line. Same thing here, perpendicular, and same thing here, perpendicular. Okay, what else? The line segments connecting the corresponding vertices will all be congruent to each other. Nope. Just looking at it at a glance, you can tell. N prime, that segment, it's much smaller than M prime. So there's nothing that makes these lines connecting corresponding vertices be equal in length. So they're not going to be congruent. The line segments connecting the corresponding vertices will all be parallel to each other. Sure, they are all perpendicular to the reflection line, and they are all parallel to each other. See how they're all going the same direction? So yes, they are all parallel. Okay, so let's see how we did. Boom. Okay. Alright, so that's it for this video. Make sure you take good notes before you try again.